Hi, my name is Utkarsh and I'm doing a presentation on welding racing cars. So these are the type of welding that we all know, that is spot, gas, laser, explosion and magnetic pulse welding. So magnetic pulse welding is basically a less known welding form, but then that's the focus of the presentation. So what is magnetic pulse welding? It's a solid state welding which is done by high impact of velocities. So these are the parameters that are involved. So the jet speed is nearly 300 to 500 meters per second. Then the pressure enigma. So what happens here is, in this method, two workpieces collide with each other at such high velocities. So they undergo a plastic deformation which eventually ends them to weld or fuse together. It's a molecular level or atomic level welding, so it's really strong, and since they don't have a initial heat source, so the temperatures are not that high, and it's a cold process, and hence it solidifies really quickly. So this is a setup. So this is a copper electromagnetic foil. These are the work method pieces, the flyer and the parent. So once the capacitors are charged, the coil is charged, and hence it produces electromagnetic forces which pushes the flyer on the parent. And as we know, the velocities are really high, so once it comes down, the impact angle alpha varies continuously and the velocity increases accelerating. So what happens is, when it comes down, the air trapped in between the workpieces is pushed out. So with the air pushed out at that speed, it takes away all the oxidants and the dirt with it. So the weld is really clean and precise. This can be seen from here. It's a weld between aluminium and steel, and this is the work surface interface. So since I've told that magnetic pulse welding has not been researched, it's been known since the World War II, but then not much efforts were taken to actually study the process. So I didn't find many journals or research papers on them. So the ones that I found are Couples and Abbe's experiment. So they did was one of the first experiments done using this format of welding. So they took aluminium and steel sheets and they tried to weld it together using the method, which they succeeded in a number of attempts because of the various parameters to be controlled. The parameters may include the voltage of electromagnetic coil, the eddy currents generated, the temperature, and the place where the experiment is conducted. Since the setup is really huge, it needs a bigger space. The second experiment done was by Stephen. He attempted to fuse a thin aluminium sheet to a steel alloy tube to create a wedge, and he succeeded that by manipulating the different voltages and current combinations, and then he ended up with the required results. Lastly, SK Khan had planned to reinforce his aluminium chassis with steel. So he used the magnetic pulse welding method to do the same. He ended up deassembling the chassis, the aluminium chassis, and then forging it with the steel using the method, and then reassembling it. So eventually the whole chassis was reinforced by steel using the method. So these are the properties that these journal papers found out. So the first one would be, it's a cold process. Weld dissimilar metals. No filler metal is required. It's stronger than the mother. No heat affected zone. It's highly precise. No distortion, and there's no chance of corrosion. So these are the various combinations possible for this method. The flyer can be either aluminium, copper, brass, steel, stainless steel, or nickel. Whereas the parent can be titanium, magnesium, nickel, stainless steel, steel, brass, copper, and aluminium. And these are the ways in which they can be fused together. Not all parent metal can be fused with the flyers, but the intersection of all those are the cases are actually possible. So what is the research output or the gaps? So here we know it's a very highly repeatable process. It can be repeated for mass production using a algorithm based program. Since it's a complicated algorithm, it has to be a constant one for a huge number of productions. Second, these similar metals can be welded. So before this method, the only other method that could weld the two dissimilar metals in such high precise manner was explosion welding. But that caused deformations. But this doesn't cause any deformation, or there are no surface wedges. So this is a really good method for mass production. Then it's a green process. The rules of every country regarding the environment are going stricter and stricter every day. So the industry needs a environmental friendly method, which magnetic pulse welding is. There are no heat affected zones. So basically the workpiece outcome is, it actually does not need any post processing unless required. Then the gaps would be, one of the two metals should be a good conductor of magnetic energy, because when it pushes the other one, it has to interact with the magnetic force to accelerate at that velocity and make the weld happen. Then it's not possible for very thin or very thick sheets. Very thin sheets would actually break or might shear off due to the impact velocities, whereas very thick surfaces are possible, but then the setup would be really huge, which is actually non-economical, or no machines or no setup has been created yet to do that. So what is the research question? The research question here is to check the performance of a magnetic pulse welding setup to weld thin aluminum or magnesium alloy, which actually has a lesser magnetic conductivity, whereas it's highly conductivity to electricity. So the material that I am focused here is magnesium alloy and steel alloy. So this is the research design. All we need here is a magnetic pulse welding setup with the required clamps and fixtures. Also we require electromagnetic copper foil and a bank of capacitors. The workpiece might be placed somewhere between 15 to 20 millimeters apart. The capacitors are charged and the weld takes place in less than 15 seconds. It's a high quality interface weld. So these are the benefits of using a magnetic pulse welding machine to a conventional welding machine. The process that we eliminate using the magnetic pulse welding is decreasing, cleaning, straightening and heat treatment. Also the advantage it gives add-on is the reworkability. It's almost 95 to 98.5%, whereas it's just 2 to 5% in the conventional methods. Conclusion, the welding of aluminum alloy to a steel alloy is successful because if the various parameters are controlled enough. So the parameters would be electromagnetic coil voltage, the eddy currents, the temperature of the surrounding, the impact velocities and the thickness of the worksheets. These are the references used during the entire research, and yeah, that's it. Thank you.